Hi class, in this video I'm going to continue to talk about circle geometry properties, and right now we're on properties for perpendicular to a chord. So for these properties there's going to be quite a bit of verbiage, so if you want to pause the video to take a look at the verbiage, you may. This would be the first set of verbiage, and now you have this verbiage here, and finally this last verbiage. So let's start from the top. Basically what this property states is that if you have a chord. So let's say you have a chord right here. So A to B is a chord because it goes from the edge of a circle to another edge without passing through the center of the circle. It states that if you have anything that goes through the origin, like for example a radius, it will bisect that chord into equal parts on both sides. So what that means is, for example, if A to B is 20 centimeters, A to C is now 10 centimeters, and C to B is now 10 centimeters. So it just got bisected in half. Um, and once again, that radius or any line that goes through that center, it could be a diameter as well, must pass through the origin or the center of the circle pretty much. So it has to be a radius or a diameter or something like that. And also it forms a 90-degree angle where it bisects. So for example, here it would be 90, and here as well, both sides, it would be 90. So let's go over an example. Here I have radius CD. So C to D bisects the chord A to B. The chord A to B measures 8 centimeters in length. So A to B is 8 centimeters. Okay, let's write that down. A to B is 8 centimeters. Okay, the radius of a circle is 5 centimeters. Great. So that means C to D is the radius, and also A to C is also the radius. Notice A to C and C to D are the same. So they equal to 5 centimeters. What is the length of the line segment CE? So we want to find CE using this property to help us. So C to E, we don't know what it is, but that's what we're looking for. Okay, so here's what we can do. Because we know that this radius bisects the chord into equal parts, we can say now that A to E would equal to 4 centimeters, and alternatively, E to B would also equal to 4 centimeters. But we actually form something else here. And notice one more thing about this property. Where it bisects, we're going to form a right angle as well on both sides. But we're going to focus on this side in this case. So looking at that, we actually formed ourselves a right angle triangle, if you think about it. So this right angle triangle, I have my right angle here. This is A to E, and A to E is 4 centimeters. I know what my radius is A to C. It's going to be 5 centimeters. So now all I'm missing is this side, which is C to E. So I'm just going to let that be X in this case here. So I have a Pythagorean theorem question. So again, in this case here, A squared plus B squared equals to C squared. In this case, I'm just going to let A be my X squared. B will be my 4. So I got 4 squared, and then C is going to be 5, so 5 squared. So in this case now I subtract 4 to the other side, so I get x squared equals to 5 squared minus 4 squared. I take the square root of both sides, and if I do that, I just get x on one side. The other side, I'm going to have the square root of 5 squared minus 4 squared. In this case here, 5 squared is 25, so 25 minus 4 squared, which is 16. So I'm going to end up getting x equals to the square root of 9, because 25 minus 16 is 9, and the square root of 9 is 3. So my answer to x is 3 centimeters, and x is just the length for CE here. So I found CE, so I can just say CE equals to 3 centimeters.